Hello friends, welcome to the channel 5-minute class. Today we will take few more examples of the time complexity. So we will take few pieces of the code and analyze them and find the time complexity. So let us start. So let us see the first piece of code. So I'm just writing single statement inside this loop. So you are already familiar with this code for I equals to 0 to I less than n, I plus plus. So this will take n plus 1 time and this will take n time. So we are not going to consider this time because when we write the complexity of the algorithm, that is represented in terms of order of only, and we just consider the degree of the polynomial. So the degree of the polynomial would be n. So this n plus 1 can be ignored. Okay. So the time complexity of this piece of code would be order of n. Let us see the second. So in the second example, the loop is starting from I equals to n and going greater than 0, I minus minus. So this loop is also similar to the previous one. Here it was going from 0 and going up to n, and here we are starting from n and we are going up to 0. So either we go from 0 to n or from n to 0. The statement will be executed for n times. Okay. Definitely this loop will take n plus 1 time, but this can be avoided because the complexity is represented in the form of order of the degree of the polynomial. So here it will be represented as n. So either the loop is running for I equals to 0 to n or it is running for n to 0. The complexity would be order of n.
तू समझा? हाँ. नहीं, तू समझा नहीं.
Next, I equals to 1 and we are going up to I less than n, but here I is updating for I equals to I plus 2. So this loop will not be running for n times. Since it is updating for I equals to I plus 2, so this statement will be repeated for n by 2 times. So if the time function is n by 2, then the complexity would also be still the same, that is order of n. We go of n because the degree of the polynomial will not be changed. Either it is n by 2 or n by 30 or n by 40 or n by 100. Means whatever is the number of times it is updated, the loop, the degree of the polynomials will not be changed. So the complexity of the algorithm will be order of n. Next. So we are already familiar with this code. Here we are using the nested for loop. So definitely this loop will be taking n plus 1 time, and inner loop will be repeated for n times, and the statement would also be repeated for n times. This loop will take n plus 1 time. This loop will take n plus 1 time. This would also be repeated for n times. So the complexity would be order of n square. Okay. Let us see this piece of code. तो यहाँ पर भी जो है दो फॉर लूप हैं, नेस्टेड फॉर लूप हम लोग यूज़ कर रहे हैं. सो हाउ मेनी टाइम्स it will be executing. It is also looking like the previous one, this one which we have just seen before this current example. So there we had also taken the 2 for loop. Both the loop were running for n times. Okay, but it is somewhat different from the previous one. Here it is the outer loop is running for I equals to 0 to n, and the inner loop is running for 0 to I. So definitely this is not running for n times, as was the case of the previous example. Okay, so we have to analyze it. Okay, so how to analyze? Suppose ये I की वैल्यू हम लेते हैं J की वैल्यू, and let us see how many number of times the statement is executed. So first time when I equals to 0, so the second loop will run for j equals to 0 to j less than 0. So j equals to 0 and 0 less than 0, so this condition is false. So this will not be running for even a single time. Okay, means it will be 0 times. The statement will be repeated for only 0 times. Means the statement will not be executed. Okay, now second times when I equals to 1, so this second loop will be running for j equals to 0 to j less than 1. So first it will be going for j equals to 0, it will be executed one time. So now j equals to 1, so this condition will be false because 1 less than 1, so this will not be executed, means 0 times. Now I equals to 2, so this loop will be running for j equals to 0 to j less than 2. So it will be running for 0 value of j, so it will be executed for one time. When it is the value of j is 1, then it would be executed one time, and when the value of j becomes 2, so this condition will become false because 2 is less than 2, so this will not be executed, means the statement will be executed for no times, means the statement will not be executed. So here it will be executed for only 2 times, here 1 times, here 0 times. Let us execute one more times. Suppose I equals to 3, so this inner loop will be executed for j equals to 0 to j less than 3. So the statement will be executed for j equals to 0, then it will be executed for j equals to 1 because this condition is still true. Then for j equals to 2, this is still true because 2 is less than 3. Next 3, so when j becomes 3, so 3 less than 3, this condition is false, the statement will not be executed, so it is executed for 3 times. So means you can see that if I equals to 1, it is executing for 1 time. If it is 2, it is executing the statement for 2 times. If I equals to 3, it is executed for 3 times, and so on. If I equals to n, so it will be, the statement will be executed for n times. So how many number of times the statement will be executed? That is 1 plus 2 plus 3 plus up to n, so which is nothing, n into n plus 1 upon 2. So this is what your time function f of n. So what is the time complexity? That is order of n square. Okay, so either it was the previous example where we had seen that the 2 nested loops were running for 0 to n, and here the loop is running for I equals to 0 to n and j equals to 0 to I. The time complexity is same, that is order of n square. Okay, let us see this example. Here p equals to 0 and the for loop is running for I equals to 1 to p less than n, and p is updated for p equals to p plus I. So definitely this loop is not going to be repeated for n times because it is starting from 1. It is not I less than or equals to n, it is p less than or equals to n. So at least one thing is sure, that this statement will not be repeated for n times. So how many times this statement will be executed? Okay, so let us analyze this. So we'll take two values I and p. So when I equals to 1, initially p was 0, so p equals to p plus I, so it will be 0 plus 1, that is 1. When the second time the loop will execute it, the value of I would be 2. So the value of p would be updated for 1 plus 2, which is 3. Next time when I equals to 3, so it will be something 1 plus 2 plus 3. When it is 4, it will be 1 plus 2 plus 3 plus 4. So ये loop कितनी बार चलेगा? Okay, we do not know. Let us assume that it is repeated for k times. So we can write, definitely it will not run for n times, because here p is less than or equals to n. If it was I less than or equals to n, then only this loop will repeat for n times. Since it is p is less than or equals to n, so we can't say that it will repeat for n times. So let us assume that it repeats for only k times. Okay, so we can write the value of p as 1 plus 2 plus 3 plus 4 plus dot dot k. So this p can be written as k into k plus 1 upon 2. So now let us see when this loop will be terminated. So the loop will be executed for this condition while p is less than or equals to n. Means the loop will be terminated when the value of p become greater than n. Okay. So here the value of p is this one. Suppose this is the condition that it is executed for k times and the loop is terminated. Okay. So the value of p that moment of time would be k into k plus 1 upon 2. That should be greater than n. So if we write this expression, then roughly we can represent this expression as k square should be greater than n. So the value of k would be greater than square root of n. So this is what is the time complexity, that is order of square root of n. Okay.
और अभी तो रुको, क्लाइमैक्स अभी बाकी है.
Now let us see this next piece of code. So this is also looking similar to the previous examples, that here we have the for loop for I equals to 1 to I less than n, and it is updated for I equals to I into 2. तो यहाँ पे I equals to 1 से I less than n जा रहा है. इसका मतलब हम blindly नहीं कह सकते हैं कि ये आपका n times चलेगा, because the value of I is getting updated for I equals to I into 2. Okay, so let us analyze the value of I. When the loop will be starting, then the value of I would be 1. Second time when the new value of I updated, that will be 1 into 2, that is 2. Third times, you can see here the previous value of I is getting multiplied by 2. Okay, so next time it would be 2 into 2, that is 2 square. Next time it would be 2 square into 2, that is 2 to the power 3, and so on. So how many times it will be repeated? Suppose that is the value for the value of 2 to the power k. For the value of I as 2 to the power k, the loop is repeated. Now when the loop will be terminated, the condition is I less than n. Means when I become greater than or equals to n, the loop will be terminated. So let us assume that the value of I is 2 to the power k, for which the loop will be terminated. Okay, so we can write 2 to the power k should be greater than or equals to n, or we can say 2 to the power k equals to n. So what is the value of k? If we take the log of both sides, log of 2 to the power k equals to log of n. So value of k log 2 equals to log of n. So k can be written as log of n base 2. So this is the time complexity of this piece of code, that is order of log of n base 2. So what we can analyze, if the code is if the value of I is updating for multiplication by 2, then the base is 2. If it is updating for by multiplication of 3 or 4 or 10 or any number of times, so that will become the base of this log. Okay, आई होप आप लोगों को ये वीडियो पसंद आया होगा, तो प्लीज़ इसको लाइक एंड सब्सक्राइब करें. थैंक यू.